Hello, my name is Ton Lee, and this is my final project for EEC 10. First off, I'd like to thank our Professor Chua, our TA Scott, and Wakaz for all the help they did throughout the labs. So our current configuration is a dual channel mic connected to our board and through the MyDAC, and also the tibia connected to the computer as well. And then the tibia is also connected to the servo, which is under there and mounted. And what I'm going to be showing you today is currently the time recording, and the filter, which is a part of it. And our current setup right here, we have the unfiltered wave, the filtered wave, our principal frequency, our bandwidth, and we can change these when we are actually running the program. So this current configuration allows us to set a recorded time, so which we will start recording. And I'm going to set this to 1:0. So basically how this program works is that it'll take a set input time of recording, and it'll have a system time, and it'll just compare the system time to the recording time, and if the recording time is greater than the system time, it's going to trigger the recording. And how the filter works is that you will set a principal frequency and bandwidth, and the bandwidth is basically the range of the frequency from the principal frequency which the mic will record, and it'll filter out all the lower frequencies and all the higher frequencies from that principal frequency bandwidth, and it'll output data to the graph, and it'll generate a sound file. So my current configuration, I have it set so that it will start recording at 1:14, so we just have to wait for 10 seconds. And what you'll see is that the unfiltered wave and then the filtered wave will have a kind of like cutoff right here because, okay, it's currently recording right now, as you can see. It takes a little bit for the delay, but then you can see the difference between the two microphone powers. So our microphones are right here and here for left and right channel. And you can see if I talk louder in one of the microphones, you should see a sharp jump in the graph right there. Okay, I think we're done recording, and I'll go open up the file right now. It's in Documents. You can kind of see some fuzz when the playback is happening. That's because due to the filter that we implemented, and our principal frequency is pretty high. So what I'm going to show you next is the sweep, the partial sweep. And for that, I need to borrow. Can I get? Okay, for our next project implementation, we did our partial sweep, which basically compares the amplitude of the right and left channel, and whichever is greater is going to turn that direction basically. And then it's connected to our tibia, so the servo is going to move clockwise or counterclockwise depending on the difference between the two amplitudes of our microphones. So here's a demonstration. So it's basically comparing the differences between the two microphones, and whichever amplitude is greater, it's going to turn in that direction basically. And that's my final project. Thank you for watching, and see you next year.